So I hope you'll have read about trees and you'll are now familiar with all the terms that we have done. Okay. Today, what basically we need is for our next topic how we do the numbering of the trees. So if you all have not revised this concept on trees, I just request everyone to open your books and check out how the numbering we have done. Last time I had shown you how to do the numbering when we were studying. Just check out how we have done the numbering, because our next topic is directly related to that. We are going to use the numbering and we are going to represent your binary tree. Just look in your books how you have done the numbering. No, Siddesh, not BFS and DFS. That is for graphs. Okay, so basically, can anyone let me know what is a binary tree? What you have understood by a binary tree? You can type in the chat. Can someone type in the chat? Nobody? Cheryl, can you tell me what is a binary tree?
It is a finite set of nodes that is either empty or consists of distinguished node called the root, and remaining nodes are partitioned into disjoint sets, and both of them
Okay.
are binary trees.
Yeah. So your disjoint sets are called subtrees, and they again form a binary trees. Okay, in short. So uh, yeah, Nikhil, you can't say node having maximum two nodes. You have to say maximum two children. Okay, you have to just term this, write it properly. So mostly every node will have two children, left child and right child. Okay, so that is a binary tree. Also, what is the difference between a tree and a binary tree? Is a binary tree a tree? Obviously, the answer is yes. Binary tree is a tree. But is every tree a binary tree? Is every kind of tree is a binary tree? No. Okay. Like I had shown you on the very first day when we started with this topic, a tree can have more than two subtrees. Okay, it can have multiple subtrees for a node. But whereas a binary tree will have at most two subtrees for each node. So a node cannot have more than two subtrees. Okay. So let's continue then with our topic that we were doing. So our next topic that we are doing is how to represent these trees. Okay. Basically, we are looking at how to represent binary trees. So there are two ways of representing binary trees. One is using arrays and second is using linked list. Okay. Uh, the general way of representing trees while doing programming is we don't use arrays. Okay. Because we have already studied the limitations of array. Like the most basic limitation of an array is it is a fixed size. Okay. So if you want to change the size of your tree dynamically, you cannot change the size of your array because you have already declared the size of the array and it can't be changed. So most common way of programming is using the linked list. So we use linked list to store our tree. Okay. We look at both the ways how it is to be done. This is an important question. Okay. So it could come for 8 marks for you. They'll give you a tree and they'll ask you to represent it using arrays. They could ask you to represent it using linked list. It's very simple. So I don't want any one of you to be losing any marks if this question comes. Okay. Especially when you're using arrays, all you have to do is proper numbering. If you do your proper numbering, array representation is very easy. And linked list is even more easier representation. Okay. So we look at both of these quickly and then I'll go to the next topic. So looking at the array representation, suppose this is a binary tree that has been given to you. You start numbering. Okay. In the last lecture, I've already taught you how this numbering is to be done. So you number your tree starting from 1 from the root node. Okay. Once you have numbered it, once you have numbered this tree, you draw one array at the bottom here, like how it is shown here. Okay. And again, you can see the maximum number in your tree that you have drawn. The maximum number of that in your tree is 15. So you will draw an array starting from index 0, okay, all the way till 15. So you're going to draw an array like that. And then based on the number that you have here for the node, you're going to store that value of that node, whatever alphabet is written there or number is written there, in the corresponding index of the array. So for example, P, you have given the number as 1. P will be stored at index 1. A is given the number as 2. A will be stored at index 2. B is the index given number as 3. It will be stored at index 3 and so on. So all you have to do is look at the number that you are given and store it in the corresponding index in the array. And this thing is known as the array representation of your binary tree. Okay. So in array representation, there are two steps. You will be given a binary tree. No numbers will be given on it. So you have to do numbering. Okay. So the first step will be you have to do numbering. So you will start with numbering with the root node, like I showed you last time. Once you have done the numbering, you will get something like this. The second step is draw the array. How many elements you have found, that much should be the size of your array. In index 0, we don't store anything because we do not have any 0 number node here. There is no node with 0. So 0 is left blank. Okay. And all the other nodes from 1 to 15 are filled. So suppose there was some node here that was not there. It was missing. In that corresponding position, you would have left blank in the array. So for example, this 5 was not there, say. Okay, this 5 node was not there. Then at its index 5, you would have left blank. You would have not put any value here. Just left blank. Only put the element in the corresponding index. 6 is here, put in 6. Whatever is missing, you have to leave it. Okay. So this is your array representation of binary tree. Any questions about this? You can type in the chat or you can unmute and ask. So anyone is having any question? Okay. Is there any question here? Why we can't start from 0? Siddhant. Yeah, Siddhant. Like last time I taught you, we start our numbering from 1. Okay. So since in the binary tree we are starting from 1. Okay. Since we are starting from 1 here in our tree, we don't have any node with value 0. The numbering is not starting from 0. Okay. So if your question is why we can't start from 0, you could have started, but normally when last time I taught you one formula, remember this formula that I taught you, this formula. Okay, this formula will not work if you start from 0, because we are assuming that k equal to 1 is the root node, and then we are telling the left child of the root node is at 2k and the right child of the root node is at 2k plus 1. If we take k equal to 0, then this will come as 0. Answer 2k will come as 0. 2k plus 1 will also come as 0 plus 1 1. So the answer will start coming wrong. Okay, this formula will not work then. So that's why in order for that formula to work, left child, right child formula, we start with k equal to 1, where k equal to 1 means that first 1 will be the root node. Yeah, I hope it answers your question.
So the K is
So,
an index of the array, right?
what k will be address of the array? Yeah, correct.
Yes.
Index, yeah, correct. Index of the array. Yeah, k is the index of the array. So you have to just number it. It's very simple. Just draw one array, number it. Whatever maximum number you have found in your this tree, we have found 15. So since you start from 0, you have to draw 16. From 0 to 15 is 16. 16 elements you will draw in the array. They will be blank. And then you just fill it up. And that is your answer. And if you do this correctly, you will get 8 marks. Okay, it's not very difficult. So I'll proceed then. If you have any question, you can type in the chat box. I'll see it later. Okay. So let's go to the next slide. Look at this now. Look at this diagram. Okay. Only this leftmost diagram where my mouse is circling. So when you're given this, first of all, do the numbering. Okay. So when you do the numbering, you will get like this. To like last time I had mentioned to you all, missing nodes also you have to consider. You will get a numbering like this: 1, 2, 3, 4, and 5 and 6 is missing. Okay, so C's number will be 7. So once you have got the numbering like that, okay, draw the array. Draw the array. See, 7 is the maximum number that you have. When you draw the array, you will start from 0 and go all the way till 7. Just put the corresponding values. K will be at 1, P at 2, T at 3, R at 4, C at 7. 5 and 6 is blank because the original tree is not having any nodes at 5 and 6. Now this middle tree you need not draw. Okay, in case you are an expert, I would suggest you not to waste time in your exams and draw this tree. It's not needed, this one. Okay, this one is not needed. If you know to do the numbering directly, you just do numbering. So this will be 1, 2, 3, 4. Then you know here 5 is missing, 6 is missing, and this will be 7. And then store this here. And this is your answer. Okay. Same way now for this diagram you see here, the second example. Draw the missing nodes. Okay, here the nodes are missing, so draw them. If you want, you can draw them, others you can leave them. If you get confused, you can draw them. Okay, draw them like this. Once you have drawn them, then number them. When you number them, number only the nodes that are present. So you will get this is 1, this is 2, this is 3, 4, 5, 6, and 7. And store only these nodes in the array. So you will store H at 1, M at 3, and D at 7. So most of the times they will give you like this type trees where the nodes are missing, and you have to draw the missing nodes and then fill up the array in the proper way. That is, the index numbers in the tree and in the array should match. Okay. So have you all understood both of these examples here on this slide? Any questions about this slide? How you represent? This numbering part I'm not explaining you again because I've done it last class. I think that you should be able to understand. So any questions on this slide? Okay, I'll proceed then. So I hope are you all noting it down? What is being shown to you, or I can share the slide also with you, or prefer you to note down this quickly and make your own notes and write down. So when I share the slides, I will not be on the slide. Nothing is written. So if you make your own notes, is better. So this is your array representation of binary trees. Okay. So before I proceed, I'll just give you one. You can try one on your own. So suppose I draw a tree like this. Draw this and represent it using arrays. So what I've written here, if you can't read it, A, B, C, D, E, F. A, B, C, D, E, F. So number this quickly. First of all, number it. And after numbering, you have to put it in the array. First, tell me the numbers before you start drawing the array. What are the numbers of A, B, C, D, E, F? You can type the numbers in the chat. All of you are getting different well numbers. Saish, 1, 2, 3, 4, 6, 8. Okay, let's see then what are the numbers. Since all of you are getting different numbers, let's see what should be the numbers. Okay. First of all, draw the missing nodes. In case you are getting confused, draw the missing nodes. So here there is one node that is missing. Okay. Here there is one node that is missing. Then this one could have had a left child, could have had a right child. This missing node could have had a left child, could have had a right child. Number it now. Okay. And now from this node onwards, the other nodes are not important because they are on the right hand side. Till F, you have to draw the missing nodes. On this last level, you need not draw the other missing nodes after F. If you want, you can draw, but they are useless. Okay. So you just number it now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So all those students who have written these numbers, who have got F as 12, they are correct. Okay, so you got A as 1, B as 2, C as 3, D as 4, E as 6, and F as 12. So the others who made a mistake, look at the way that the diagram should have been completed. Okay, the missing node that is here, 5, the number 5. that one's also the missing nodes left child and right child should also be drawn 10 and 11. So I think some of you forgot to draw this 10 and 11 are calling F as 10. So that is wrong. And I don't know how Saish has done numbering. Okay. So please, many of you all had made a mistake. I can see a lot of you all are having 10 as the final answer. So that is not correct. Okay. So from those people who have typed the answers here, only 3 students have got the correct answer here. Ria, Yash and Vibhuti, Nikhil and some more are there. Steven and Rutvi. And out of 58, only some 8 students are typing. So I don't know about the others. Okay. So I hope you have understood. So this is the way you should have got the answer for your history. So let's proceed then. The next type of representation is your linked list representation. So when you are representing your tree in a linked list, again you are going to have a node. Okay, so your node will be like this. And it will be having 3 parts. So there will be a data part. Okay, so some nodes, some value will be there, A, B, whatever. And then each node will be having a left child, because this is a binary tree. We are representing a binary tree. So each node will be having a left child and a right child. So again, this node will have some address. Like last time we have already seen, every node has an address. And there will be a left child and there will be a right child. Again, the left child will be having 3 parts. The right child also will be having 3 parts. So if a left child and a right child is not present for a node, what common sense tells you what will be the value of left and right pointer? What is the value of this L child pointer? Suppose B is not having a left child, what will be the value here? And if B is not having a right child, what will be the value here? It's just common sense now that you have done so much of programming, you should understand.
Null.
It should be null. Correct. If you are not having any more nodes on the left side and right side, you should put the value here as null. So you will put here null. Okay, I'll just write here n. If B is not having a left child, you'll put null. Again, it's not having a right child, you put here null. Similarly, C is not having a left child, put null. Not having right child, you will put null. And like this, again, these nodes will be having some values. Okay. Now, if this B's value address is 200, that means here what value will be stored? 200. Because this one is pointing to the node with the address 200. Okay. Similarly, if this is 300, the right child means this will be having value as 300. Because that is the address of the right child. So like that, similarly for the other nodes it will be. Okay. Remember this. Okay. Again and again it will not be told. You should understand now like this. If henceforth only like this one pointer may be drawn like this. This 200 may not be written. Okay. This value also may not be written. But you have to understand that a diagram means like that. Some value will be there here. Okay. That value, whatever is there, is here. Therefore, this pointer is come. That is the way you have to understand now. Okay. Please note that. Because when you were studying at the starting, you all were not, it was a new topic for you, so everything was being written. So now in your textbooks and all, it will not be written like that. Even I may not write like that. So you should understand it now. Okay. So this is your structure of your node in a binary tree. Going to the next slide, let's see how to represent your tree using this node structure. Okay, linked list. How to represent it using linked list. So suppose this is a binary tree. Again, like I showed you in the previous slide, node here in circular form will be actually stored in the form of like this. Okay, in the form of a rectangle having three parts, like I just explained: the data part, left child, and right child. And each node will be having an address. Now in this textbook, the address has been mentioned on top. Okay, so it does not matter as long as you understand what it is. So just understand these values before I go to the next slide. Okay. We are never going to write like this. This is just for your understanding. All this part is just for your understanding. We're not going to write like this. Okay. Now just look at this. A is having left child as B and right child as C. So look at A. Where is A? A is here. Okay. A's memory address is 400. Left child is B. B. So where is B? B is here. B's address left child is address is 250. Therefore here it is 250. Okay. Now they have shown you all the nodes separately. Okay, it's still not put in the link list form. I'll show you in the next slide how to put it in that form. Right now they've just shown you all the nodes with the memory addresses. What are the values of left child and right child? A's right child is at address 780. So where is 780 here? 780 is here. What is that value at 780? C. Like you can see here. Value is of that node is C. Okay. I think this you have understood. Is it okay? A's left child is at address 250. Value is B. A's right child is address 780. Value is C. Similarly, C's left child is at 870. Okay. You can see here. How you know? Here it is given. C's left child is 870. What is that 870? G. You can see here left child of C is G. Right child of C is at address 200. What is that? H. Okay. Similarly, everywhere it is given. In this case here in this diagram in your textbooks, instead of writing null here or writing N, they are shading it. Okay. So in your exams, I can accept both for the value of null. You can either shade it like this to tell it is null, or if you want you can write there null. Both the things I will accept for you if you do it for your exams. In your textbook they are shading it. Okay. So when it is null they are shading it. So it means H is not having a left child. Also H is not having a right child. As you can see here. It's a leaf node. Okay. So if you are having any questions, you type in the chat. I will come back to it later. So I think this is okay for now. We'll go to the next slide. So in the next slide, let's see how to represent. Now these are all the nodes. Okay. What they are showing you is the memory allocated for all the nodes of your binary tree. And the next slide, they will show you how to put it in a linked list form. It's pretty simple. Okay. Look, this is the original binary tree. Okay. Now your nodes were already allocated here. These are all your nodes that were allocated. So A is here. So you draw the node for A. So you will draw it like this. Okay. A. We'll draw the node for A. Okay. That is your root node. Then left child is B. So you draw one more node. So you draw one more node like this. B. Since this B is the left child, you draw one arrow from here to here like this. So you start it from inside. You have to make sure you start it from inside here. Okay. Don't start it from the border. You start it from inside here and go all the way to this node here, B. So you start it from inside and come here. Okay. Similarly for the other this, start from inside, come here. So you will come here. This will be C. Okay. Then if B is, look at the original. How you come to know? Look at this original. This will be given to you. So this one you have to convert to this format. and it is pretty simple. So once you have drawn this A, you have drawn this B, you have drawn this C. Look at B. It is having a left child. So you draw this node. Draw this node. D is not having a left child and right child. So they have shaded this portion. Similarly, B's right child is E. So they have drawn this E. Okay. E is having only left child but no right child. So they have shaded this portion. Okay. And draw the left child for E. So E's left child is F. F is not having left and right, so shade it off. And similarly, they have done on the other side here. Okay. So structure should remain the same. You are having A as the root node. So A is the root node. Left child of A will be B. Right child of A is C. Just like this diagram here. And then B's left and right child are D and E. So here you are drawn D and E. C's left child and right child are G and H. So you have drawn G and H. And E's left child is F. So that is what you have drawn here. Okay. There is no need to write the addresses like it was shown to you in the previous slide. That's why I was telling you that slide. We don't show that. It was just shown to you because you have to understand that those numbers are there. The addresses are there. Left child will have some address. Right child will have some address. Each node has its own address. In order for you to understand, that was shown to you in the previous slide. Normally when we draw, we are going to draw like this. Okay. We are not going to draw all those, and we are not going to write all those numbers. So we are going to draw like this. But you have to remember that there are now some numbers like that. A is having some left child, will be at some address. A's right child will be at some address. A itself will be having some address. All that is not shown when you draw. Okay, but you should not forget that all these addresses are present. You don't need the values, but these things are there. That is what you must know as a computer engineer. Okay. So before I go any further, let's see if anyone has any questions about this. Anyone has any doubts about linked list representation? Okay, I think you all have understood. Okay, so then this was the last slide of our this topic. Okay, the basics. So before I proceed with the next topic, let me give you a small exercise. You can draw the linked list representation for this tree. So just draw the linked list representation for this tree. So if you have drawn, I'll draw here so that you can check. So for the root node, you will draw one node. Okay. So you will have here A. Left child is present. So draw this. So you will get here one more node. That node left child value is B. B is having another left child, so you will draw one more node. So that will be C. Okay. Now C is not having a left child and right child, so you will write there as null. B is not having a right child, so you will write as null. Now you write the whole thing, okay? NULL. For me, it becomes little difficult to write with the mouse, so I'm just writing N. So again here you will write A's right child is not there, so you will write this as null. Okay. So this is your diagram. So again, note how I have drawn. You have to draw start from inside here. Okay, start from inside, like how it has been done here. Start from inside. Your arrow has to start from inside. In spite of telling for exam what you will do like this. You will draw the node, everything correct, but your arrows will start from outside. And in spite of telling, it will be drawn like this. And I'm going to cut marks for this. When it is not, it has to start from inside. So when it has to start from inside, make sure it starts from inside. Okay, you don't draw it and you draw it the own way you want, I will cut your marks. Okay, so I hope you got this answer. Any questions about how I got this answer? It's okay. I think it's pretty simple, but if still someone is not understood, you can let me know. All should be getting this 8 marks of this array representation and linked list representation. So any questions before I proceed? Sir, our pen diagrams okay in exam. Try to draw with a pencil, I would say, because pen diagrams normally I would not accept it, but now I don't know, because if you draw in pencil and I don't know how you are going to answer the exams also. If you are answering the exams offline, then you have to draw with pencil. And if you are answering online, then maybe you can draw with pen. Okay. As such, I don't know. Normally, you are supposed to draw diagrams with pencil, so better to follow that. Take a dark pencil and draw. Unless that's when you take a photo and make a PDF, it does not come proper. Then it is okay with pencil. Especially for this exam, we can see in the IT you will have something of trees. I don't know what it could be, but trees will be there. So I don't know. We can try this time for the IT and see if it's not coming proper with the pencil. Then we can discuss. Okay. So let's go on to the next topic. The next thing that we are going to look is the binary tree traversal. So there are two ways of traversing a binary tree. Okay, two different ways. One is using recursion and one is using no recursion. So today we are going to study the recursive method. Okay, and non-recursive method I'll be doing after IT. Okay, so that will be done later. Today we'll be just looking at recursive method. So in both the methods, in recursive and non-recursive, there are three common methods: pre-order, post-order, and in-order traversals. Just like your prefix, infix, and postfix, those names are same. Instead of fix in expressions, we call it as fix because okay. But here we will call it as order. So in order, pre-order, post-order. So those are the three terms for your traversals in binary trees. So one by one we'll go through this. These are the three common ones, and there's one more fourth one known as level order. Okay, we look at that level order also today. So let's go through it quickly. Okay. Again, it's simple, but pay attention. Again, this is a common question for your exam. So as it is written here, when you do a traversal, each element of the binary tree is visited exactly once. Visited means we go to that node exactly once. Okay, visit means going to that node. So whenever we visit that element, whatever operation you want to perform on that element, you can perform. Okay, display, change the value, delete that value, insert some new value, whatever you are doing, that will be done during that visit. So these are your three traversals: pre-order, in-order, post-order. Okay. So normally we don't mention the fourth one, but there's a fourth one known as level order. Okay. Since these three are commonly used, we mention this, but there's a fourth one known as level order. Okay, this is that fourth one, level order. So now let's look at how to do the traversals using recursion. You can just note down the steps. You're going to need the steps. Just write down, then we'll see how to do this. You can write down or take a screenshot, it's up to you. So what you need to remember is you can remember like in short form like this. Pre-order means you remember this word visit. Remember that letter V. Then you have to traverse the left subtree, so L. Okay. Then you have to traverse the right subtree, so R. Pre-order means you will have to remember this V, L, R. So V stands for visit, L stands for left subtree in pre-order, and R stands for right subtree in pre-order. Basically, pre-order means you have to remember this code B, L, R. If you were writing a program, then we would have done something like this. So we would have passed the pointer, okay, and then we would have visited the nodes like this. So first you visit, then using recursion you would have visited the left child and visited the right child. So like I told you, you are having V, this is V, left L, and right R. Visit, left, right. Right now I'll not be telling you how this recursion works. Okay, later on in one of the programs I will tell you exactly how this works. Then you can come back here and check this. Okay, so I'll take one example and explain you in detail how recursion works, and then maybe you can understand how this works right now. So right now we'll only see how to do a pre-order traversal. I'll not explain you any of this code. If you're noting it down, you note it down quickly. So let's take one example. I would want you all to draw this tree on your books quickly. I'll show you how to do a pre-order traversal here. So remember, when you're going to do this traversal of pre-order, order is V, L, R. Okay, this is the important thing that you have to remember. Whenever you say visit, okay, that means whatever is the value of that node should be put in the output. Okay, so visit means you have to print the value of that node and put it in the answer. Okay, that's why I've written here like this. Let's see how to apply this. So your first step will be always visit, second step will be always left subtree, and third step will be always right subtree for pre-order. Okay, so let's start from here. Always start from the root node. Okay, understand this. Okay, if you understand this on one, if you understand, the other two are very easy. So if you understand pre-order, post-order, and in-order are similar. Okay, just pay attention now, and any doubts you can ask me. So you start with this first, visit. So when you say visit, just write down here for your reference. You say visit, and you will have here output somewhere. You can write here output. So this is a pre-order traversal output. Whenever you write here V, whatever is the value of that node, write it in the output. So you will write here A. Okay. So after that, go to the second step. The second step says, since you are trying the second step, write it down here. So you will write here L. Okay. The second step says, go to the left subtree in pre-order. So you check if there is a left subtree for this node. Check. Is there a left subtree? Yes. There is a left subtree. Since there is a left subtree, go to the left subtree. So you will come here. Okay. When you come back, when you come to a new node, you start with the first step again. So you start with this again. So you will visit. You will visit. Whenever you say visit, put the value in the output. So you will put this in the output. After that, go to the second step. Since you are trying the second step, write it down here. Okay, write it down here. Check whether there is a left subtree. There is no left subtree here. No left subtree. Okay. Go to the next step. Since you are going to try this step, write it down here. Okay. Check whether there is a right subtree. No right subtree. No right subtree. You have done all the three steps for this node. So go back. Go back. Okay. Now when you come back here, you have already done two steps. You have already done two steps. Which is the step that you have not done for this node is this one. This step you have done, V step you have done, L step you have already done. You have written here because you have done. What you have not done is the R step. So try to do the R. R means, write it down here. R. Check whether it's having a right subtree. It is having a right subtree. So go to the right subtree. So go here. Okay. When you come here, again start with the first step. So when you come to the new node, again start with the first step. So when you start with the first step here, you will visit. So whenever you say visit, you're going to write the answer, the value in the answer. Okay. After that first step, try the second one. Since you're going to try it, write it down first. Then when you try it, nothing is there left to go to the third one. That is right subtree. No right subtree, but since you're trying it, write it down. Now when you check this entire tree, you have done all the three steps. Okay, on all the nodes you have done the three steps. That means this is your answer. So if you are asked what is the pre-order traversal for this tree, the answer is A, B, C. Clear? Is it okay? I'll come to the chat. You let me know if you have not understood. Did you all get it? Siddesh, for what you are asking? More number of nodes? Okay, so this is the way you are going to do this pre-order. Okay, so you will get the answer as A, B, C. So you all can try this. Use the same thing and try by yourselves. You are going to use this visit, left, right. Try it by yourselves. Tell me the answer, what you are getting. Type in the chat. So are you getting it? Anyone has got the answer? Okay, some of you have already typed the answers. So let's see how to get it. So you start from the root node. Okay, start from the root node. So you will start with visit. Whenever you write visit, you will write the answer in the output. So A will go to the output. Then you will try the second step. Okay, so you will come here, left subtree, come here, visit. You will write the answer. Try to go left. So you will write here and go left. Visit. You will get here D. Try to go left. So you will come here. Visit. You will get G. You try to go left, can't go left, so you will try to go right, can't go right, so you go back here. Okay, here what is left? Right is left, so right here right, and go here to right. Okay, you have written here R and you will go to right. Visit, so you write here H. Try to go left, can't go left. Try to go right, can't go right. Okay, go back here. What is left? R is left. So write here R and go right. You will visit. You will get answer E. You will try to go left. No left is there here. So can't go left. Right? R and go right. So you will come here. Visit. So write the answer here I. Try to go left, but no left is there. So you write here L. Try to go R, but no R, so write it down. When you go back to the parent, of I, all steps are done. When you go back to the parent, all steps are done. Okay, so go to the parent of B. Parent of B is A. What is left here? Right step is left. So right here R, go right. When you reach here, visit. So you will get here C, right here, visit. Try to go left. So write it right here, left. So you come here, left, visit. So right here, F. Try to go left. So right here, no left is there. So try to go right. Right is present, so you will go right. So you come here, visit. So you will get here J. Try to go left, no left is there. Try to go right, no right is there. All three steps are done to go to the parent of J, that is F. All steps are done to go to the parent of F, that is C. Here only two steps are done. So you will try to go right. So when you try to go right, nothing is there. So you go back to the parent and all steps are done. So if you check now the entire tree, all the steps are done. So this is your final answer. Is it okay with everyone? How we got this?
So,
Yes.
so this is similar to depth first search, right? Depth
Who is
first
asking?
search, Yash.
Yeah, kind of, yeah. You have studied this before, depth first search and all?
NPTEL course somewhere
Yeah,
I've gone through it.
yeah, kind of similar it is. Okay, kind of similar. Yeah. So we'll be going to those topics later on. So I don't want to confuse the others who don't know about these things. Yeah.
Okay, sir.
Okay. So everyone understood this pre-order? Is it okay? I think you'll have got the answer also, most of you. Okay. So yeah, so all of you have got the answer. Now just be a little careful, okay? Now while this in your mobile or laptop you are typing this, letters that you are typing should be of the same case as the what is given in your tree. Okay, by mistake here Siddesh A is come capital. So please don't make this mistake. It should be the same. Uppercase and lowercase letters are having different meanings. So make sure that all the letters are of the same case as your question. Okay, so I think it's okay with most of you. Okay, so if you have understood this one, then the other ones are similar to this, so you should not find any difficulty there. You can do those. Just rub off this thing. It's easier to do it. 1 second. Okay, so this is what you all got the answer. So again, you all can just take a print screen of this and you can try it later. Take a print screen, all of you, and try it later. Whether there are symbols, there are numbers, or alphabets, the rules are the same. It does not matter. Okay, nothing changes in the rules. So you will get this answer at the end if you have done correctly. So, and it will give you the prefix form of your. If you were doing, you have already know what are prefix, infix, and postfix. If you do a prefix traversal of a tree, you would have got a prefix form. Now this is something known as an expression tree. Okay, maybe this later at the end of the term, if we get time, I will teach you what is this expression tree, how to construct it. So right now you just know that there is something like expression tree where you can convert your expression in the form of a tree. Okay, when you do a prefix, a pre-order traversal, you get a prefix expression. Okay, so let's look at the next type of traversal, in order. So this is the steps for in order. In order will be traverse the left subtree in order, then visit the root node and traverse the right subtree in order. So basically in order will be LVR. So your pre-order was VLR. This was your pre-order, okay? What I written on top, and this is your in order, LVR. So you have to remember this basically, okay? And the full steps are like this: traverse the left subtree in order, visit and print the road, traverse the right subtree in order. So I hope you all are getting it. I don't know how much. I can't see you also. I can't make out whether you all are understanding and no. But I hope you are getting it. So can you all just try this? Just try if you. Let's see if you have understood the previous one. And this should be simple. This will be left. First step is left. Then you visit. Visit means you have to write the answer in the output. And then third step is right. Can you just try and see? I'll just give you 30 seconds, then I will solve. Okay, now I will solve. So if you have not done it or you have done it, you can see the answer. So first you always start from the root node, okay? All the traversals have to start from the root node. You cannot start from anywhere. So start with the first step, L. Okay, write down L. Check whether there is a left subtree. If there is a left subtree, you have to go left. So since you are writing here L, there is a left subtree, go left. Okay. So again, when you come to a new node, start from the first step. Try to go left. So write here L. There is no left for this. So try the second step, visit. Whenever you write visit, you have to write the answer in the output. So you will put B in the output. Okay. So after visit, go to the third step. So try to go right. When you try to go right, then nothing in the right. So go back to the parent. When you come to the parent, first step you have already done. Do the second step. So you will say visit. When you say visit, write the answer. After that, try the third step. Try to go right. So write it down before you try. Check whether there is a right subtree. So there is a right subtree. So come here. New node. So start from left. Write it down. Go left. Then visit. So write here V. Write it in the answer. Okay. After that, go to this. So you will write here right. Try to go right. So when you try to go right, nothing is there. So when you check the entire tree, you have done all the tree steps. So this is your output. Any questions here? Anyone has not understood? It's similar. Once you have understood one kind of tree, it is the same thing, except the order of that LVR will be different. So pre-order means you're visiting before. Visiting is before, and then you're having LR. Okay. In means just like an infix expression. The symbol was coming in between. So like that, your visiting will come in between, and your LR is on the opposite sides. So pre means before. In English also pre means before. Similarly, post order. What will be post order? LR will come first and visit will come later. Okay, so this will be a post order. We'll see this. So is it okay with everyone here? Yeah, you're getting the answer. Then let's do the next one. Okay. You can take a screenshot of this and you can try this in order. You should get this answer. Okay. Just take a screenshot. If you are not getting it, we can solve it in the next class. Do this in order example and you should get that answer. Try it later. In the evening you can try it. See whether you're getting this answer. Okay. There's one very simple way of doing in order getting the answer is you can get the answer like this. Okay. Start from your leftmost element and write down here. So you write G, then you write D, the next leftmost, then the next leftmost, and so on. And when you do like that, you will get the answer like this. Okay. This you can do only in order. This is a what you can say a cheat method of doing things. Okay. Not it's not any recursive method or non-recursive method, but I'm just showing you in case you're running out of time for your exams. But and this works only for in order. It does not work for pre-order or post-order. Okay, so you have to know from where to apply this. But again, if you do like this for exams, I'll cut your marks. Okay, if you show me that you have done it like this. So you have to be this same answer you get if you check. So don't show me these arrows. Again, you can try this for given an expression tree also you can do the same thing. You will get the answer for in order. Okay. So there are two more types of expressions, post order and level order. I'll do it next time. Okay. Already we are, it's almost time up or it's already past the time I think. So we'll stop the class. I'll stop the